All right, how you guys doing? It's been a lot going on this week.
Oh yeah, long week, a lot of really exciting stuff.
Hopefully we can send, this isn't the last thing, but directionally send things off with a bang here. And now each of you helped us kick off PROGCRYPTO with 3 different keynote talks. And so it's really great to have this chance here to chat with each of you, perhaps explore some of the topics further, as well as get like a cross-pollination of ideas. For anyone out there watching either here or in the future, it's all right if you didn't see the keynotes, but if you haven't, definitely recommend you go check them out. I'm sure they'll be up somewhere soon enough. And as for today's conversation, for me, it's always a joy and a pleasure to chat with each of you because I learned so much from each of you, and this is a chance, hopefully, to share that experience with the audience. One thing I noticed was that thematically, the keynotes, I think this was an accident. I'm pretty sure you guys didn't coordinate on this. But the keynotes sort of accidentally, they had a real flow to them, right? Vitalik started at this like higher, almost philosophical level. And then we went to Gubsheeps, which was this overview of programmable cryptography. And then Barry helped us dig into a specific, I guess you could call it an up-and-coming branch. I mean, it's not that new, but there are some reasons why it is where it is, and that's something I'd actually love to dig into more later on. So I'm going to sort of mirror that progression in terms of steering today's panel, but I'm sure we'll like branch off and bounce up and down, like the various Zoom levels. But to start, the theme of Vitalik's talk was cryptography as defensive technology. And I wanted to explore an angle that you didn't really have time to, I think, in your talk, but something that I've heard you talk about in other places, so I thought it'd be great to share with this audience here, which is that defense isn't just about doing less. And what I mean is, at least when I hear defense, it sort of creates this imagery of battening down the hatches, like bolting up your windows, not going outside, or maybe you're wearing like heavy body armor. It's like cumbersome. And even in your talk, you mentioned, hey, we accept 1000x overhead to code in Python for convenience, why not accept 1000x overhead potentially for some of these other properties? And I think that's something that's absolutely, I certainly would consider that, and I think a lot of other people will too. But at the same time, in general, there's long been this like privacy versus convenience trade-off narrative when it comes to cryptography and probably other systems that are related to that. Whereas the angle that I'd love to explore more is how increased defense can actually enable you to do more, right? Like one lens I have on defense is you're being more precise in a particular way. Like, maybe you could think of wearing armor as a precise way to not have an arrow like strike you in the heart. And of course, it's not like a binary like thing. But the general idea is that defense can give us more precision about the nature of our interactions, and that can also be really useful and strong in other ways. And so like the specific thing that really triggered all this for me was, Vitalik, you've said that interoperability and robustness are 2 sides of the same coin. And that really stuck with me. Can you expand on that? And of course, we'd love to hear from Barry and Gubsheep as well after.
Yeah, I mean, I think the interoperability and robustness. Yeah, the way that those two naturally play into each other is that one of the challenges of interoperating more is that you end up having more links, and those links could end up being more vulnerable, right? So Henry Farrell recently wrote this book called On Weaponized Interdependence, and he basically explored the history of how a lot of the technological interdependencies that got created, like for example, between centralized tech systems that are largely based in the US and their users across the entire world, created choke points that could then be exploited for other reasons that were not even considered when those networks were being built out at the beginning. And basically what you have there is you have a push for interoperability coming at the expense of robustness. And one of the backlashes to that we've been seeing over the last decade is basically a greater push for like technological nationalism of different kinds, right? And basically, like pushing to try to rely only on technological networks that are being developed locally, or locally in relation to wherever you are and whoever is making that decision, and that like on the one hand addresses the concern, but on the other hand, it like creates this pretty horrible splintering dynamic where like basically a lot of the benefits of globalization risk getting thrown away, and we basically risk getting into the same kind of spiral that we did with protectionism in the 1930s in the last century. And if we have robustness, like if we can find a way to interoperate with robustness, then that might be the only thing that can like get through some of those barriers and some of those pressures, right? And look, one example of this is open source software, right? So in general, even as centralized networks get attacked and blocked by a lot of these recent political trends, open source stuff generally does not, and generally people around the world are willing to trust open source because they know that it is a piece of code. The piece of code is out there. Once it's out there, you go download it, you go fork it, and it's not something that can just decide to make itself disappear or turn against you 2 years in the future. And that gives it an ability to keep the world interoperating in a way that centralized networks sometimes can't. But the problem with open source software is like, open source software by itself does not have a shared hard drive. And it turns out that lots of interactions that we want to have need a shared hard drive, right? And like blockchains are an example of something that actually tries to provide that shared hard drive. Some of zero-knowledge proofs are an example to try to create a different kind of interoperability, so not so much a shared hard drive, but more a kind of common language that lets you take any of these information links and turn them into a privacy-preserving link and a link that follows the same standard, right? Like whatever the thing is that the link was originally, you kind of put it into one of these snark wrappers, and it becomes privacy preserving, and at the same time, it becomes a verification key that follows like a particular format that's the exact same format for each and every one of them, right? And so there's a lot of really powerful benefits that come out of that. There's like examples of this all the way up and down the stack, right? Like if you even think about like people building things on top of Twitter, right? Like recently Twitter made that big change to their policies where they massively increased the price of the APIs, and they made it not possible to look at tweets unless you're logged in. And this really broke a lot of like applications and people that depended on interacting with Twitter in various non-conventional ways, right? And like that's another form of interoperability without robustness, which leads to problems. But if you have interoperability with robustness, as you do when, for example, you're building an application on top of Farcaster where all the messages are on a chain, then like you actually, like Farcaster does not just like have that same ability to rug you, right? Like if you go and do something that's connected into the very specific feature of Warpcast, which is a particular centralized UI, then maybe. But if you build on top of Farcaster itself, the open source protocol, then like, you're actually not getting rugged, right? So, yeah, I think that's something that's powerful, and it's one of the guiding philosophies that's really underappreciated that we could build a lot more on.
Yeah, absolutely. I think, one word that robustness also reminds me of is the idea of hardness that I know Josh Stark has been talking about lately. I remember when I first came into Ethereum, one thing that really struck me during things like, whether it was like the DeFi craze or the kind of discussions around what might be possible with fully on-chain gaming or things like this, was the degree to which interoperability was made possible specifically by this notion of like hardness or robustness. So when I think about how many degrees, how many like levels deep can you go in terms of like the third-party stack with, let's say, the traditional, let's take like the Apple App Store as an example, right? So like Apple builds the iPhone, distributes iOS to a bunch of people, has an app store that allows you to download and run apps on that. Well, we can kind of look at how many like levels of successive independent development can be built on top of that. You might have like level 1 is you have something like Uber or Instagram or these companies that will build apps that directly get distributed via the App Store and then will themselves expose APIs to third-party developers. And then you might have a second level of apps that are like oh, check who unfollowed you on Instagram, or like, here's a third-party app that allows you to like see your like Uber stats as a driver or a rider or something like that. But you don't really see like a third or like a fourth level of that kind of composability. And whereas within, let's say, like 1 or 2 years of something like the DeFi craze, as much as sometimes we point at this for being, we point this out for being like circular, you do get to see those like 6th or 7th level derivatives, because you know that the foundations and the links that every successive level is built on top of have that kind of hardness or robustness. And that is a property that I think blockchains, as well as cryptography and programmable cryptography especially, give us. You move from this paradigm where fundamentally, if you're building in a world where your building blocks have like an 80% chance of crumbling to dust under you, you can build like a 2 or 3 story house at most. But once you start getting like concrete or steel, or like, I think of cryptography and cryptoeconomics sometimes as like digital material science. Well, you can start building skyscrapers. You're in like a qualitatively different regime, and that's where that interoperability and flexibility really starts to shine.
Just to build on what Brian was saying, a lot of people think that like programmable cryptography is a tool for like doing defensive stuff, and this brings this like limitation or limited mindset to like what's possible and what to do. And I feel like the framing of like robustness enabling us to build like more complicated things that we weren't able to do before is like a better way to approach the problem, because we don't want to make like a ZK version of like things that already exist. What we want to do is use programmable cryptography to make a more robust world, so that we're able to build things that are just not possible right now.
Yeah, so like building on this theme of, we're not necessarily zooming in and trying to narrow down what we're doing. We're actually trying to enable and unlock new patterns, things that are really just bigger, taller, proverbially speaking. Here's a framing that, through conversations with you guys, has really jumped into my mind of late, and I'm curious to play with it. I don't think it's actually that accurate, but I think it might lead us somewhere interesting. So I'm going to throw it out there, which is, what are like almost the analogs between programmable cryptography and something like the web browser? And that doesn't seem like there's much of an analog at first. But what I mean by this is something that Vitalik, you and I have talked about, which is one of the reasons that the user experience has gotten better on, say, Linux in the past 5 years is the amount of stuff that is just browser first or browser native has gone up a lot. And so just naturally, as a result of that, you can use, there's things like, I don't know, Figma, Airtable, Notion. There's a lot of examples of things where, as long as you've got a browser, which does work pretty well on most Linux, in most Linux environments, then you will be able to have the same experience that somebody using, let's say, a Windows or a Mac computer will have. And so when you guys are talking about, hey, there's this flexibility, interoperability, those types of words, it very, like a lazy pattern matching of mine goes to something like the browser, which sort of like slides in between the operating system and the application in many situations. Is there something to this? Like, what are some ways maybe this parallel actually makes sense? And definitely also, what are some ways in which it doesn't?
So I think that modern cryptography or programmable cryptography can be this interoperable layer where you're able to have this ability to compose together different cryptographic primitives that already exist. That we have a lot of cryptography in the world, and it feels like up until now our priority has been to make some new cryptography and verify it. But I think in the future our priority is going to shift to verifying already existing cryptography. When you're able to do that, when you're able to bring all of these systems together, it can become a very powerful tool. So in some ways, I think that ZKPs are WASM, right? They're just this standardized framework that anyone can do anything inside.
Yeah, I'm glad you mentioned that, because that's one of the more, I think, underrated things that happened in the history of browsers in the past 10 years, which is the emergence of WebAssembly and some of the things that I just mentioned, such as Figma. They basically wouldn't exist or wouldn't work nearly as well without WebAssembly. And it's kind of fascinating because it's a pretty interesting example of real-world coordination between the various browsers, something that I would say it's fair to characterize as a positive-sum game and has led to some benefits for everyone, although maybe I'm missing some downsides here as well, so please let me know if I am. But it's a lesson that like, hey, if quote traditional tech can do something like that, maybe we should be able to share that mindset in sort of developing out the ZK, programmable cryptography, et cetera, world. And in fact, like, Vitalik, you'd said something at one point about, I think it was, maybe I'm getting the exact framing wrong, was it like ZK snarks are the transformer of cryptography? And transformer here in like a precise kind of artificial intelligence sense. Can you unpack that a bit? Because I thought that was like a really interesting lens on it all.
Yeah, so transformers are the design pattern behind GPT, right? So the T stands for transformer, and the GP stands for general purpose. Basically, yeah, it's a particular type of AI architecture, and the thing that came about as a result of it is basically that like there's this huge set of different use cases, translation, like finding grammatical errors, responding to questions, like
image recognition.
Image recognition, yeah, giving you facts about the world, assisting people with coding, like a really big long list of things. And there's been a long tradition of lots of really dedicated and specialized work with many thousands of man hours going into each and every one of these tasks. Like people really trying their best to build entire companies around like optimizing things for these particular tasks. And then that just all got completely swept away by this new general purpose paradigm that just like outperformed all of these specialized things across like thousands of applications without even trying, right? And the ZK Snarks, I think, have really created a similar kind of sea change within the crypto space, right? Like if you think about the way that we thought about many kinds of cryptographic constructions before the ZK Snark era, you would think about like fraud proofs, for example, and the complexities around fraud proofs and the complexities around making fraud-proving games work, especially when you're not sure whether or not data is available. You would think about things like state roots and like blocks having root hashes of the current state inside of each of them. You would think of like how Ethereum has logs inside of it, and you have Bloom filters to make it easy to scan across all of them, and just all these different things. And once you have ZK Snarks, the correct way to think about all of these problems just completely flips over its head, right? Like, even if you think about something that was like a heresy 5 or 10 years ago, like the idea that Ethereum should contain state roots, right? Like, in the pre-ZK Snark world, Ethereum having state roots in the blocks is like a huge benefit over Bitcoin because you could have light client proofs that actually prove the current state and not just specific events that happened. But now, even if Ethereum did not have state roots, anyone could just go and basically just like make a sidecar object where that sidecar object would just come with a proof, and that proof would just say, this is a proof that says that the result of executing a block on top of this state actually that has this root hash is this, and the proof is also going to point to the actual Ethereum block, and then the proof is also going to point to a previous proof, and then you have a big chain of proofs that goes all the way back to Genesis, right? And like, this, the cool kids call this PCD, but it's basically, like once you do this, then you realize that like, wait, this entire functionality can just be done as a second layer off chain. And then you think about Plasma and like how it just becomes 10 times easier to do any of it once you just assume that everything is Snark proven by default. And yeah, like it just completely overturns like a lot of basic like principles in terms of how you think about making so many different blockchain constructions.
Yeah, I really like that example because it illustrates how the state root is kind of this special purpose guarantee. And if you don't have that special purpose guarantee, you can still kind of construct it through this general purpose like technique. And that's the parallel as well with transformers and AI. And I don't know if Gubsheep is one of the cool kids, but he did bring out this PCD framing a lot. So maybe we'll dig into that a bit more down the road.
PCD stands for pretty cool dude, so he counts.
Cool. So you were self-branding yourself. That makes actually a lot more sense to me now.
One more thing that I actually want to add on here. I want to try on a slightly different hat and talk a bit about the idea of programmable cryptography for off-chain interactions as well. I think that one really interesting lens through which to see things like ZK Snarks is like it's technology for interfaces. So in general, going back to these examples of like, WASM and the browser and stuff like this, a lot of these things, like the reason that they're useful, one way to look at them might be you have sort of, n kinds of inputs or sources or something on one side, and you have m kinds of like receivers or recipients on another side. And ordinarily in the world, naively, if you don't have some sort of like portability technology, you're going to need to build n times m different bridges between the different things. But if we can find these sort of interoperability layers, you might only be able or you might need to only build something like n plus m connectors. And when we think about something like WASM, we're basically matching up, okay, here's all these different like hardware architectures and operating systems with all these different applications. You don't have to distribute a different version of each app for each operating system or each hardware architecture. Similarly, with something like ZK snarks or programmable cryptography broadly, we're going to see that same effect between, for example, like data sources and data silos. An example in this room that folks might be familiar with is like different L2s or like plasma validiums or things like that. But this can, of course, be extended to all sorts of different data sources and data destinations.
Yeah, I've never heard parts of that from you, and that was really helpful for a lot of reasons, including it helps illustrate how we might be reducing what would be a combinatorial explosion into something that isn't, right? And as we kind of know, like the entire cryptography space depends on this. Well, it's like an exponential explosion. Turns out everything fits in like 2 to the surprisingly low number space. And so yeah, whenever you see this like reduction from that to something else, that completely shifts the landscape of like what is possible. And so overall, it's been clear through the keynotes, through even where this conversation is going, that we're seeing a very interesting new-ish space, not really even begin its journey, but still be in the very early stages of its journey. And so, especially with the combination of you three up here, I'd be remiss not to explore a little bit more like how the future of, let's just call this programmable cryptography, how might that future like parallel the journey that we've seen from blockchains, Ethereum, we can pick wherever there, how might it differ? And because, again, especially with Barry and Gubsheep here, like you guys are 2 of the primary progenitors, I think, of this field. I think our friend Jordi Baylina also deserves a shout out for his role, and obviously Vitalik's role in Ethereum is well understood as well. So yeah, like we can really go in any direction, but just sort of kick things off. For better or for worse, it's hard to disentangle the blockchain space from ideology. Right? I think it is not technically have to be intertwined, and yet we've seen that in practice that it is. And so that's something where I'm curious whether we think it will look similarly when it comes to programmable cryptography. But we can also go in a lot of other directions, so take what comes to mind.
One immediate thing that I think about is the extent to which blockchains are sort of default financialized, like the sort of defaults for an application that you are building on chain. And this doesn't have to be true. Like there's many ways to use like the data availability or ordering guarantees of blockchains for other things as well. But because a lot of the space originated with cryptocurrency, by default, whenever we think about something like games or identity, there's an impulse to jump to, okay, how can this be made fungible or financialized, or how can I have shares of this, or how can I trade or transfer that? I think that is not a default affordance of cryptography in the same way, which has a lot of advantages and disadvantages. I think on net, probably it's advantageous in the long term. The disadvantage, of course, is that like a lot of the reason why so much funding has been able to flow into cryptography has been a side effect of the fact that blockchains have drawn so much financialization kinds of attention.
Yeah, like to build on that, like there used to be like this idea of like key signing parties where people will go to each other's house and like sign each other's public key. This was like an effort to try and make like cryptography more available in the world, or to give it more meaning. But like that movement didn't really succeed in the same way that frogs succeeded, right? I mean that like people now, there's like 60,000 frogs have been issued. So there's 60,000 signatures available that people can use and transform and do whatever they want with. And like, there's still a lot more to be done with the like frogs direction. But I feel like when you think about what we do with when you think about like blockchain versus like programmable cryptography or like what's possible, it seems to be that like most of there's a lot of incentives around cryptography that help to bootstrap the cryptocurrency or the programmable cryptography world.
Yeah, one of the frames that I've used when thinking about the future of crypto for a long time is the kind of the three paths of Esperanto versus Linux versus the internet. Esperanto is an artificial language that was invented by Ludwig Zamenhof in the late 19th century. And the goal was to try to be like simpler than existing languages, have a more regular grammar, make more sense as a language, but also to have one single thing that everyone in the world could learn, and with the hope of creating a more peaceful world by helping people to understand each other, right? So it's this like pattern that has a very deeply ideological purpose infused inside of it, and it has it acquired a lot of fans, and it has a large enthusiastic community even today. But in terms of practical impact on the world, it's been fairly marginal. Then the middle path is Linux, which of course also has very ideological roots around wanting software to be free. And Linux is an interesting one because there has been a long multi-decade-old movements to try to get people to use Linux on their desktop to replace Windows and Mac. And lots of people do use it, like I use it, but it's still like very far from 100%, and it never gets anywhere remotely close to like even 10%. But then at the same time, Linux runs the back end of a whole bunch of servers, forks of Linux. I have Android, which runs a whole bunch, most people's phones. It's different kinds of open source software everywhere, and so it's this weird middle path where it's gained like some level of mainstream adoption, though often at the expense of diluting some of its principles. And then there is a purist wing that has some level of interest, but definitely still like very far from the hopes of its adherents. And then you have the internet, which definitely had lots of ideologically infused effort put into its creation, and then it ended up taking over everything, right? And the question is like, which of those three is crypto going to end up being the closest to? And I feel like so far we're definitely at a kind of Linux level of trajectory. Can probably be a little bit more optimistic than Linux even. The question also is like, where is programmable cryptography going to end up? And I think what's interesting is like I can see like all four kind of quadrants in terms of the possibilities, right? Like I can see a world where both of them start taking off more and more. Also, I can see a world where both of them just continue to end up pretty marginal. I could also see a world where programmable cryptography ends up kind of really leading the charge and making more inroads than blockchains do. And I think the strongest case for that is that, like, we talk about blockchains as solving trust problems, but the kind of trust problem that they solve is like literally, fear that the centralized guy will edit the database in the wrong way. And that's like not the primary trust problem that most people have when they think about distrusting centralized like software actors. The biggest problem that most people have when they think about centralized software actors is privacy. And then the second problem is like, if there are algorithms that they are running, then like, how do you even know anything about what's going on in there, right? And ZK snarks are just an insanely powerful tool for solving both of those problems. And like, if you look at Zupass, for example, like that even as is already very usable as, let's say, a government identity product, for example, right? So the case for PROGCRYPTO kind of shooting ahead of blockchains is basically like just getting that level of, that it has that extra level of utility. The case for blockchains getting ahead of programmable cryptography is kind of a bleaker world. I think it's the world where all of this like openness and decentralization and trustlessness stuff just like never appeals to more than a few people, but people wants to trade their digital gold and their monkeys. So that's realistically what I think that fourth quadrant is like. I mean, in terms of like which of these I want, I mean, I admit I'm kind of torn because on the one hand, like actually making a global impact on a large scale is, I think, really what all of us are here for. But on the other hand, I think there's a case to be made for giving both spaces a chance to grow further on their own and to be in an environment where they actually, instead of having like lots of individual silos create applications that individually try to integrate into the mainstream and accept lots of sacrifices by doing that, really work to create an integrated ecosystem where the different parts of the new ecosystem make sense in the context of each other and really kind of build that out, right? Like basically trying to make this kind of intentional, like science fiction LARP of, enacting the universe of like what would the decentralized future actually look like if all of the different pieces had to be done that way, and then like giving it that push to really push it to this like very high and very integrated level of quality, and then from there breaking out more. So yeah, which of these will happen? I'm not sure of, but I see the cases for both sides, but I mean, I expect it will end up being somewhere on the middle in both cases. So we'll see.
My take about this is that I think that like if blockchain succeeds, it will pull programmable cryptography up, and if programmable cryptography succeeds, it will pull blockchain up, so that they're just
what if Bitcoin succeeds? Because Bitcoin is the only real digital gold, and Ethereum is like a centralized pile of crap. And the way that people use Bitcoin, because you can't corrupt Bitcoin by using the blockchain, is by holding accounts at centralized exchanges. Will that pull programmable cryptography up?
Yes. So what I think will happen is that we will, like the rise of Bitcoin will necessitate the improvements in programmable cryptography so that you're able to verify ZKPs inside Bitcoin signatures. And that will mean that like we'll be able to have like ZK rollups on Bitcoin. But I think that Bitcoin can't succeed without that technology advancing.
Interesting.
One framing that I think we might have even mentioned in last year's version of this panel was that there's this interesting sort of complementary affordance set where cryptography gives you the power to say whatever you want about arbitrary, hashes or key pairs or whatever. But you still need some sort of device that allows everybody to agree, like what hashes and key pairs and stuff like that actually matter to talk about. And the strongest sort of hardest technology that we have for that today is a blockchain.
I thought you were going to say the New York Times.
Well, that's actually interesting because I think we can actually imagine now, with the fact that programmable cryptography exists, a more cohesive path from existing, let's say, like whether it's institutions or infrastructure that we do use to make data meaningful, towards putting more of that onto the blockchain. You can sort of imagine going from like taking like a Web 2+ approach to blockchainifying the world, where you start with like, yeah, maybe the New York Times is hosting via some like trusted API endpoint a Merkle root of like all of the news stories or something like that. And people can make proofs about that. People can like, encrypt that in interesting or different ways to send back and forth. And then you might imagine this progression where, well, the natural place to post that kind of Merkle root is on chain. And then suddenly you've got applications where it's like, all right, you've got the Merkle root of the application is posted on chain. And every time there's some sort of state transition in the application, there's a ZKP that the authority that was doing that updated the application state correctly. Maybe they don't put that root on chain and they just serve it via some like highly available replicated kind of infrastructure. But the point here is I think programmable cryptography gives us a way to not have to be like all or nothing, like, hey, insert X complicated social backend here, can we replicate that entirely inside of a smart contract? It gives us a way to progressively achieve the guarantees we want.
You mentioned last year's panel, and so the four of us got together about a year ago at Devconnect in Bogota, and one of the reasons I was really glad to have a chance to do another panel this year is because last year we, or especially I, joked that we'd reached a point in the space where people were just saying ZK to mean everything that wasn't just kind of old school cryptography. That was like almost the highest level takeaway of what to know about zero knowledge is that it doesn't mean zero knowledge anymore. And I'm glad to do this panel this year, especially with this backdrop, because I think we can contribute to the solution and not just point out the problem a bit more, which is that you sort of have this wider umbrella. It's not an all-encompassing umbrella, but this programmable cryptography concept, I think, does a better job more accurately conveying the space of things. And it also lets us sort of disentangle ZK from this like accidental umbrella term to like sit in a more, again, more precise place in the tech tree or so on. That's something that you showed during your talk, for instance, which was like a cryptography tech tree. One thing I was curious about is like, why did ZK in multiple senses get so far ahead? Because my understanding of the history of some of these technologies, whether it's like true ZK, like technically accurate ZK, and then even snarks above that, even if those are not necessarily zero knowledge. And then there's, you know, multi-party computation or two-party computation, then there's other parts, like other branches in that tree. So what happened exactly that pulled ZK ahead? Because historically, if you go back, I think, say 10, 15 years ago, there wasn't such a large distinction where things were.
I mean, I feel like this probably relates a lot to the previous question or previous topic around the relationship between cryptography and blockchains. And you know, the sense that I get is that there's, and I don't really have the best way exactly to describe it, maybe Barrier Vitalik might, but somehow it feels like ZK and blockchains have been sort of a more natural fit in terms of the short-term complementary affordances than necessarily some of these other branches. And because blockchain has dominated so much of the sort of tech narrative over the last couple of years, drawn so much attention, so much, you know, resources, so much intellectual energy, that's probably been an example of blockchains pulling up a particular leg of programmable cryptography that makes a lot of sense for blockchains in the short, medium term.
Yeah, that's exactly it. We just had a lot of problems that we needed to solve, and ZKPs helped us to solve those problems. They were the right tool for that time.
But I guess, you know, maybe one question is like, why not MPC? Like, why aren't we living in a world where everything is, you know, two-party computation, bridges, or two-party computation, privacy, such and such, so and so?
So you can think of this as by thinking about ZKPs are objective, right? You can make a proof and just share it, but MPC is subjective, which means that like it means different things to different people. So if you have a ZK application, the proof is it makes sense to everybody. But with two-party computation, it's only the people who are participating who it's meaningful to. And like Ethereum is like one of the key features of Ethereum is it has this like global state that everyone is able to edit and access. And ZKPs just fit well into that domain, right? Because it's like it's a thing that you can use to speak to everybody.
Yeah, I really want to go a bit further on that because that's something that helped me understand some things, made some things a lot more clear to me, which is, well, the goal of two-party computation is, you know, for two parties to perform, for instance, a computation where they're both able to keep some information private, but almost by definition, they can obviously collude, like in that process. And that may have been obvious to the audience, but for me, that was a big like click, oh, this is a completely different regime than the one that we're sort of in when we're considering a blockchain and how people think about it and their goals. And really, in the spirit of, again, being more clear and not just doubling down on the everything is ZK meme like we might have done last year, I want to dig in further on multi-party computation because we've been hearing that term, multi-party computation. We've been hearing two-party computation. They've been used somewhat interchangeably, even though I don't think that is actually the intent. So that's something that I would like to take this opportunity to, let's start with my understanding of it, because I'm kind of the avatar for the less knowledgeable audience here. With multi-party computation, when you hear two-party computation, you're like, okay, two parties, there's a computation. But now if you have four-party computation, that's actually not a well-specified concept, right? Because when you say four-party computation, there's, for instance, all four together. There's like subsets of the four parties and how that works. And so can one of you elaborate, unpack like the difference between, yeah, like N of N party computation versus like K of N, and I think you guys have some preferences on which ones we focus on as well.
Yeah, I mean, I think within the crypto space, the word MPC tends to have a vibe of like thinking about these big, like bridges that have some kind of like 6 of 9 architecture, and then it turns out that like 5 of the 9 are on the same server, and then someone figures that out and they hack it, and $250 million goes poof. And like, the problem with that style of MPC that I think has like made me hesitant of against wanting to be too enthusiastic about it is like it has that K of N assumption, but which is worse than the K of N assumption in like blockchains around 51% attacks, because in this case collusion is undetectable, right? Like if you fast forward 30 years to a world where you have mature systems, and let's say you have 2 big mature systems, and one of them is a blockchain that is vulnerable to 51% attacks, and let's say where there are staking is dominated by 13 stake pools, and then on the other side you have an MPC that is a 7 out of 13 MPC. There are definitely going to be conspiracy theories about how more than 7 of the participants in the MPC are actually colluding with the NSA and maybe the MSS and the KGB and lots of others, and they're like actually stealing all your data. And there is just no way that you can detect that, and there will be no way to rebut those conspiracy theories. Whereas with a blockchain, if you 51% attack once, there's huge amounts of visible evidence all over the place. Even if your attack is a censorship attack, where there isn't sort of technically cryptographic evidence, there's still evidence that's extremely visible to anyone who is online, and we could go and see that, and we can go fork them out, right? So it's it's one of those assumptions that I think it feels like it intuitively makes some sense, but I think one of the things that characterizes our modern world is that there are a lot of cases where the problem isn't even too little coordination, the problem is too much coordination, right? And whenever you have 13 known people running a big piece of infrastructure, like they can totally get into the same Telegram group, right? It reminds me of that famous picture of the miners in Hong Kong at that conference lining up, and you have like a big a picture of a panel which just is, hey guys, here is 90% of the hash rate of the decentralized network. We brought them all here. They're in Hong Kong. So that's like the source of my unease of sort of unaccountable event trust models. But then if you think about 2 of 2, and I think we can abuse 2 of 2 a little bit to like include in certain instances of 3 and 3 sometimes, is that the trust model is really different there, right? So like, for example, let's say we use 2 of 2 computation to compute, let's say, my trust score in order for me to get a visa into Albert Land, right? So for me, I have on my zoo pass a bunch of different zoo stamps, a bunch of cats, a bunch of tickets proving that I once to Solo, probably a bunch of other things over the years.
Yeah, like frogs.
Right, like frogs. Then we have Albert, who has his algorithm that wants to run over my data, but his algorithm is something that he does not want me to know, because if his algorithm becomes public, then people are going to like exploit the hell out of it, and you're just going to see people like optimizing for like, hey, let's just like pop into the exact events to get you your like Albert Land's credit points and like visit them for 10 minutes, right? So if we 2 of 2 compute a function, then I maintain the privacy that like which specific things I did are kept hidden from everyone, including from Albert. Albert maintains his privacy in that I don't learn his algorithm, and both of us get the guarantee that we both learn what is my credit score, and that determines whether or not I get my Albert Land visa and can go party with the frogs full time. So in that case, like, there isn't a committee that could betray us, right? It's something where, from the perspective of either of us, the security guarantee is unconditional, because we're talking about a 2 of 2 system here. And I think there are 3 of 3 examples here, right? So like the simplest 3 of 3 example I can come up with is like, if instead of being a visa to Albert land, let's imagine Albert is running a ZK dating site, and he has a secret algorithm to decide if Brian and I are compatible.
You're thinking of GovSheep, actually.
That's
for
sorry,
running the data
GovSheep,
site.
sorry, yes. If GovSheep is, yeah, so we're trying to see if GovSheep and I are compatible, and like Albert wants to keep his algorithm secret, and GovSheep and I want to keep our history secret, including from each other, of course. Then, like that is something that can run in a 3 out of 3 and get the answer out, right? But that has the properties that are more like the 2 out of 2 than like the m out of n. And I think to me, the reason to be super bullish on sort of 2 of 2, including things that I'm sort of like ham, like square and circle pegging, whatever the English word for that is, into the 2 of 2 blocks, is that the trust assumption story is way simpler. You don't have to like spend lots of social effort legitimizing a committee, but also the technical aspects of it are much simpler, right? Because like actually, like doing an MPC technically is super hard. I remember getting an MPC wallet. This is part of why I like totally despise MPC wallets today. I remember getting an MPC wallet from this company that was experimenting with social recovery, and it was using MPC to back up the keys. And I remember like the MPC breaking all the time, and like just keys and data randomly getting lost, communication links totally like failing, and eventually ended up losing tens of thousands of dollars to that thing. But I like if you just do a 2 of 2, like that's just a link between me and you, and that's just like super easy to set up, right? So from a kind of technical and social perspective, it's just like something that is very near term, very practical, and just like has lots of use cases that make sense even in very small groups. So I think it's like a great candidate to just go and get started.
Yeah, that's really great because it hits on a few things that I think are very important, especially as I think we're moving, and we're going to talk about this, moving into an era where two-party computation becomes even more useful and flexible, which is when MPC historically tends to have this affordance of like K of N party computation. One reason we like talking about two-party computation is by definition, K has to equal N there. But another thing here to note is that sometimes you hear like a bigger N must be better, but actually that's not default the case, and in fact is often the opposite of the case. So I'm really glad we had a chance to clarify some of those things, and even just like 7 of 13 versus a blockchain's like X of Y is completely different. Not to mention you can't even tell, right, if something has gone wrong. So there's all these pieces to multi-party computation that hopefully as it becomes more of a thing that people are using, now's a good chance for us to really become aware of the nuances of what it means. Otherwise, I get to kind of sit under this, everything is ZK, like everything is therefore better umbrella, and that would not lead to very good outcomes. What we really want is every party computation, right? And what multi-party computation does not or has not generally meant that.
And the reason for that is there's this just terrible liveness trade-off. If you have everyone who is required to compute the computation, if one of those people goes offline or refuses to participate, you're not able to come to a conclusion.
I was just about to say, actually, one thing that Vitalik's multi-party computation wallet example reminded me of was another reason why ZK might have a more natural like affordance match to blockchains in the short term, which is exactly this liveness thing, which might secretly be the same thing as the subjective objective thing that Barry you mentioned earlier. But with ZK, I mean, even just coming at this from a perspective of like building a game, which I always like thinking about what games can you build as like examples of what a toy system can do. Building ZK into a blockchain game is possible with much lower complexity because there's like a non-interactivity going on between like you and the rest of the network. You know, I generate a proof, I send it out to the network, and that's like a one-shot thing. But even with like a two-party computation, if we're trying to jointly compute something about some data that is being committed to on-chain that like requires a liveness assumption that introduces some sort of like asynchronicity. And so, you know, going back to the previous topic even, like this is another example to me of where, in fact, rather than trying to fit everything like square peg to round hole for blockchains and cryptography, we should allow we should be looking at like these two systems almost as like first-class technologies in their own rights, trying to understand what they can do, and eventually everything is going to converge. Like the high-level themes here and the high-level ethos and the idea of defensive technology is there for the both of them, but it's worth exploring each of them like as first-class technologies.
Yeah, and speaking of games, I want to make sure we get to some other topics as well, but fairly quickly, Gubsheep, you built Dark Forest, and when I first saw Dark Forest, I was like, wow, that was brilliant. I would never have thought of building this. The person, building this, that was so creative, and there were so many other things that I enjoyed about it. But in talking to you, what's also apparent is it's somewhat lucky that you were able to build it, right? It wasn't like you learned all the cryptography needed or things of that sort to be able to do that. And here we've been, whether it was Barry's keynote, this conversation, we think that 2PC is something that can be used more in more places, but it's also behind where, say, snarks are right now. Can you give like a quick kind of overview of maybe contrasting, like somebody comes up with a Dark Forest level idea, except one that uses, two-party computation. What do you see right now as like the struggles they might face that, like, for instance, you didn't face when you were building Dark Forest, and what can we kind of learn from that? And Barry, you probably have some thoughts from that as well, but I'll start with you.
Yeah, no, I mean, so, with Dark Forest, there were a couple of major unlocks that made it possible. The first was really CIRCOM. I just happened to run into Jordy at a conference in 2019, and he was like, hey, like, let me show you this cool thing that I just built. And it was CIRCOM and Snark.js, and that was very, very lucky. That's sort of building on top of the, I think in my morning talk from yesterday, I had set out like a couple of the like stages of how programmable is programmable cryptography. And stage 0 is like you have a paper out for a programmable cryptography primitive, but there's no implementation that actually allows like a developer to not have to implement the paper first. And that's what, like the folks at Zcash did, is they implemented the library in order to implement their one specific circuit, and that's not something that's very scalable. When CIRCOM and Snark.js come along, you suddenly have this language that not entirely cryptography unaware, but like a non-cryptographer, pretty generalist application developer can look at it and be like, okay, cool, I can like understand the programming model here. I can like write this thing and run it through a compiler that someone else has built for me. The other thing that was just very fortunate in terms of timing, which is kind of a fun coincidence, is that this was right when the Ethereum mainnet Istanbul hard fork had just gone through, reducing the gas costs for the pre-compiles for the like elliptic curve operations that are necessary for snark verification. And so it was just like good timing on a number of things. And so what I would look for in the 2PC kind of example is like, well, what is that like stage 1 kind of tool stack? Where is it right now? And how accessible is it for building? Again, like I think about games, and I gave an example yesterday of, I've got a secret sword or a sword with secret stats. You've got a shield with secret stats, and we're like trying to compute like what's the effect of my sword on your shield. Like what is the higher level DSL that allows me to do that without needing to myself know cryptography?
Right, so like the CIRCOM, the Snark.js, those analogs they still do not exist, right, for 2PC, or do they? Or where is that at? Yeah.
Yeah, it's not quite ready yet, but there's some progress there. This is why I'm so excited. But I think the next step that we need to take is tooling. Like we need to get the CIRCOM of 2PC.
Cool. As we hit the home stretch of this conversation, I want each of you you can share one or maybe for both of these. Let's go in both the one direction, like a combination of directions. One is maybe you have like a far out idea, like something that's really, really far from possibly working at this point. But I think it's kind of fun to stretch in that direction. Like Barry, you gave some artificial intelligence therapist and two-party computation example during your keynote that I thought was a really nice example of this type of thinking. So if you have something like that, or maybe you have both, more immediately, Vitalik, you frame things under the lens of DIAC, right? And you talked about how it'd be great to see people doing more like DIAC stuff. And so I'm like,
Well, you want DIAC and you want really far out. I want to be uploaded and I want my brain to run in an NPC. Because like if all of our brains run in an NPC with the components all thousands of kilometers apart from each other, there is like no single physical location that you could blow up to kill any of us. Will have solved safety.
That's robustness. That's real robustness.
And we can take it one step further. If we get really good at formal verification, you can prove to someone that I would never do that. I would never think about that because the dopamine trade-off of that I would get from that is just, it wouldn't work.
So that's one candidate as a project for somebody. What else might somebody build if we had like a deackathon, for example?
I'll take this to being one level more or maybe several levels more grounded. I would really love to see someone actually like try to build the like sword with secret stats, like shield with secret stats, like kind of, you know, game interaction. Or even like a simple card game where like I can have like, you know, folks might be familiar with the idea of like mental poker. How do you play poker in a decentralized way? You know, there's these like commutative encryption schemes. What if you tried to like level up the interactivity of that kind of two-person game by one level, where now it's like I have a card game where I can place a trap card face down, and you can have this thing of like, you know, you've activated my trap card, and maybe here's a collaborative ZK Snark proof of what happens once you've activated my trap card. I think it'd be an interesting exercise to figure out like what is needed to actually concretely build that right now. It doesn't seem like it's that out of reach. I see Barry is
we've never had a game where you didn't reveal your cards at some point in the game. That like with 2PC, you can have a game where you just never reveal what you have, right? And that could be pretty cool. I have two ideas. One is simple, one is hard. Let me do the hard one first. So basically, the difference between ZKPs and NPCs is that ZKPs let you prove about facts, but NPC lets you explore like what's possible. And like the hard idea is to make this like a global coordination tool where we have this like huge web of possibilities, and what we want to do is work together to find the best future possibility. So we can just like go around and do 2PC with many people and try to come to this like global solution that, okay, we've searched a lot, and the best thing to happen is if Vitalik is president. And that's how we get there.
Did you include Vitalik in in this N choose 2 number of 2PCs?
Maybe that's like a really low dopamine calculation in the MPC for him.
My simpler idea is I want to make this kind of like virtual machine paradigm or experiment. That like when I was like in college, I spent some time like SSHing into servers and just like running commands, and I thought it was cool. So like I would like to do it so I have like an NPC server where you're able to go and like type in commands, but like the server doesn't know what commands you're running. And you can have this kind of like fun programs. Like you could make this sort of like robot wars game where you have a program and they have a program and your programs fight. But you find out who wins, but you never find out like what was the input to the game.
One more thing that I'll add to that, as almost just like a request for projects, is there are now 60,000 of these like cryptographically signed ZK-friendly frogs floating around, and I'm curious if this is meant to sort of be a sandbox for demonstrations of interoperability using things like ZK snarks or perhaps 2PC. I don't know actually what kinds of schemas would be necessary to make this stuff 2PC friendly, but if folks want to build like frog battling or like frog breeding or stuff like that with 2PC or with ZK snarks, there's now a live data ecosystem of a bunch of these attestations, frogs, ZK-friendly signatures, whatever you want to think about floating around, and APIs for moving them around.
2PC frog dating app.
Oh yeah. We can have a frog matching service.
Okay.
Lastly, but certainly not least, I'd like to spend a little time on how folks can get started or get more into programmable cryptography. I think one of the themes that I've learned from talking with each of you is that, you dove in and it wasn't like you knew all of this stuff. It's not like you read all these papers. I don't think you guys even
Definitely not a cryptographer,
Yeah. So can you share a little bit about just what you would say to somebody who's like, I see something interesting here, I'd like to contribute. Where do I get started? How do I get started?
I think Brian has better ideas about this than me.
Yeah, so I come at this from the perspective of like maybe like a cryptography aware application developer level. Maybe a first thing that I'll say is one hope is that programmable cryptography is supposed to be making tools with like cryptographic or mathematical hardness, this sort of interface technology accessible to a wider range of people. I think Vitalik mentioned yesterday that, you know, we want accessibility in two curves. One is like the performance curve, but the other is the ease of developer use to tap into this technology. And I think one thing that's going to be really important to kind of track and combat is the potential for like imposter syndrome. You know, we've all heard things like, don't roll your own crypto. It's like important to be really careful. Maybe there's like a social thing about like, oh, like, you know, cryptography math is like hardcore. And it is, but the point is that there now exist these levels of abstraction to use it. And that's sort of the point. And I know that for me, coming into the space, not being like a cryptographer myself, but someone interested in math and interested in like building interesting things with new tech, that was something that I definitely like struggled with a lot. You know, my first couple of years of building stuff, I would come in and I saw like, oh man, there's all these like companies and like, you know, organizations that have like raised so much money and they're like doing all this stuff. Like probably the space is already solved, but maybe I'll just like make my like little game thing or application thing over here to learn some stuff. And that ended up being very productive because it turns out the tools are actually there and the pedagogy is improving to make that something that people can actually be leveraged for without needing, you know, 6 years of formal training. Now, we absolutely need more of those 6 years of formal training people to be looking at this stuff and making sure it's secure and making it faster and like, you know, helping to bridge that communications gap. But those are some of the first thoughts that come to my mind.
Yeah, like just to echo what Brian said, I also struggled a lot when I first got into the space because like there's so much stuff that like it's you just have to just say that like, okay, I'm gonna black box these components and I'm gonna focus on learning about these other components. And let me give some advice for people who are interested in getting started to do more of the like research engineering part of the stack. So if you want to get interested into, or if you want to get experience building things with 2PC, Vitalik has a great post about garble circuits on his blog, and I would suggest that you like implement this in your favorite language and explore building some tooling on top of it. This could become the CIRCOM of MPC or 2PC. And if you're interested in getting deeper into ZKP research, there's a book called Proofs and Arguments. I would suggest to like read some of the schemes in the book and implement them yourself. This is a very good learning experience. Vitalik also has a really nice blog about Plonk, and implementing Plonk by hand is a really fun thing to do. One last thing, sorry. There's also this idea, like ZK Snark's moon math is all, like, a lot of it is just like marketing about like, oh, you should give us some money because we are very clever and we're able to do this hard thing. But like in reality, like if you can understand how to divide polynomials and you're okay with figuring stuff out, it's an accessible space. Like there's a lot of impact that people can make here. And I hope people don't feel intimidated.
Last thing.
Oh yeah, I was just gonna add one more thing to Barry's note about the, you know, Plonk blog post. There's also, I think Vitalik wrote a Python Plonk reference implementation, and I'll also shout out, we ran a fun event earlier this year called the Plonkathon, where Nolan and Yingtong helped to like refactor the Python Plonk implementation into a like basically harness for you to go through and implement the steps one by one. And I think that kind of thing, just getting your hands dirty with the code, can be really, really helpful.
Awesome. Thanks so much for hanging here. This was so interesting. I didn't even go get any frogs the entire time we were up here, which is really saying something. But in all seriousness, thanks so much for sharing your time, your wisdom, and all the great energy that you guys have brought to what we're doing. And thanks to all of you for hanging out with us here today.
Thank you, Albert.